All right, so in this video, we are going to apply an first order autoregressive process to prove or disprove the efficient market hypothesis. So we're using an AR, or first order autoregressive process to look at a strict form of the efficient market hypothesis. Let's say looking at the efficient market hypothesis. And this is an example from Rhoodridge's econometrics text. So this specific form of the efficient market hypothesis states that returns in prior weeks should not predict returns in the current week. So what we're saying, let's say RT for return. So this is our return. So we're saying the expected value of our return today, given returns of last week and the week before that, and so on. We're looking at weekly returns. We're saying that the expected value of the return this week, given historical weekly returns, should still only be the expected value of this week. If this is false, and previous values of returns or previous weekly returns could be used to predict future value of returns, then that would violate the efficient market hypothesis. And we'll say EMH for the efficient market hypothesis. EMH for efficient market hypothesis. So we're going to use a simple test, and a simple test, we're going to use the first order autoregressive process or autoregressive model as the alternative hypothesis. So our null hypothesis is going to be that our coefficient for last week's return is going to be 0. Our alternative hypothesis is that the coefficient for previous weekly returns is non-zero. It's not 0. And then for this, we assume that it's a constant variance. So we assume constant variance, and we assume everything else that make it that make this work out. So for this, and this is coming from the text, we're going to we'll run the next video. We'll do this in Python, and I'll show you how to actually run this regression and how to create this. But so we run it on NASDAQ, or New York Stock Exchange returns. So this is on New York Stock Exchange returns, weekly returns from January 1st, 2000 to December 31st, and this isn't exact because it's weekly and there's holidays and things like that in there. But over this 15-year period, we have weekly returns. So we get our first order autoregressive model, and we get RT is equal to, our intercept is 0.0005 minus 0.0654. This is for RT minus 1 plus ET for error. And the standard error for our intercept is 0.001. And our standard error for our for our coefficient is 0.035. And again, this is for weekly New York Stock Exchange returns in this given period. And in order to test this, we want to know is this coefficient, is it statistically significant that it's not equal to 0? So for this, we can do a t-test. So we'll do a t-test, and we'll divide the coefficient, so negative 0.0654, divide by standard error, 0.035. do the absolute value because it's a two-tailed test. And this is equal to negative 1.89. So this is relatively small. So we failed to reject the new hypothesis. So we fail to reject the null hypothesis, fail to reject H0. So this means that it is not statistically significant, and it is 0. And then for this model, this is a bad model anyway. So if we look at the R squared, I think it was 0.004, and the adjusted R squared was 0.003. So this is overall a bad model. So weekly returns, at least in this specific case, weekly returns are a bad predictor for future weekly returns. And this is consistent with the efficient market hypothesis. So in the next video, I'll go over how to do this in Python. And I'll show you how we ran this regression.